We start off with a couple of definitions. We need the function f and f prime to both be differentiable. And then we say if f prime is increasing, f, the original function, is going to be called concave up. And that's our new term, concave up. Likewise, we can say if f prime is decreasing, then we say the original function f is concave down. So our new terms are concave up and concave down. And we're talking about the original function, f, having these characteristics of either concave up or concave down. But this time, we get this information about f not on whether f prime is positive or negative, but rather a change in f prime, whether f prime is increasing or decreasing. And that's really where we're going to need this differentiability of the first derivative, because we need the second derivative to come into play here. We say that f prime is increasing. F prime is increasing if we observe f prime is increasing. What we're really saying is that its derivative, f double prime, would be positive. And likewise, we would say f prime is decreasing. If we're observing a function decreasing, it means its derivative, and so the derivative of f prime would be f double prime, is going to be negative. And so to see what concave up and concave down actually look like, we want to observe what it would mean for derivatives to be getting bigger or smaller. And so we say that derivatives are getting bigger here if the slopes are getting bigger. So the slopes of a function would be getting bigger if the function looks something like this. Okay. See, over here on the left-hand side, we have very negative slopes that become slightly less negative as we move on. Eventually, here at the base point, it would be slope of 0 there at the minimum value. And then as we keep moving from left to right, it becomes slightly positive and then really very positive. And so the slopes are increasing if we have something that basically looks like a U. So concave up is when the original function has this U sort of shape. And so in comparison, the slopes are getting smaller. If the function looks something like this upside down U. Okay? Because slopes would be getting smaller, they'd be starting with something very big, getting slightly less positive. Here at the peak, it would be a slope equal to 0. Then we start going into slopes negative, and they become more and more negative as we move on, continuing in the right direction. And so we really have a set of conclusions to make where we have 3 different functions, and observations about one particular function give us other information about the other ones. And so here's what our conclusions are. We say that the original function f is concave up, which looks something like this, if the first derivative is increasing, or if the second derivative itself is just positive. We also say that the original function is concave down, or it looks something like this, if the first derivative is negative. Or we could say, not first derivative negative, if the first derivative is decreasing. It's very important to be able to differentiate between a sign value and a changing value. And so we say that the original function is concave down if the first derivative is decreasing, or equivalently if the second derivative is negative. And so being able to understand these 3 things are giving the same piece of information for each one of these rows is really the key to being able to separate what it is for each one.